Assalamu alaikum. Welcome to lecture number 27 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start today's lecture discussion, I would like to give you a little bit recap about our last lecture. Students, in our last lecture, we see how a software architecture can be documented and we see the practitioner community perspective of documenting any software architecture, where we see different approaches towards software architecture documentation, and we comprehensively discuss 4 plus 1 view approach of verifying the architectural design, and we also discuss the Sonis view, which is a software architecture approach to document any software architecture currently being used in industrial applications. So students, this is a little bit recap about our lecture number 26. So students, let's start the formal discussion of our today's lecture number 27. So students, our today's lecture is a second part of documenting software architecture. Basically, in this lecture, we will discuss other three approaches towards documenting any software architecture. So students, in our previous lecture, first two approaches of documenting any software architecture have been discussed. Now in this lecture we will discuss the rational unified process approach, which is actually almost same and is derived from 4 plus 1 view approach. And then we see IEEE 1471 standard, and then we also see the base approach. So in this lecture we will discuss the other three approaches towards documenting any software architecture. So as I discussed earlier, a rational unified process is same as 4 plus 1 view model with little bit changing. So I will not give you more detail about this approach, because the reason is it is very resemble with the 4 plus 1 view architecture verification technique, because in this a view is considered as a projection of a system on one of its relevant aspects as well. And then a projection is actually emphasizes certain aspects or certain views, and it ignores the other ones as well. So the UML diagrams are normally used to represent different views, and we discuss different views in 4 plus 1 view model, like logical view, process view, deployment view, physical view, and scenario views. And all of these views are also includes in this rational unified process approach. So there is very much similarity and resemblance with the 4 plus 1 view model and the rational unified process approach. So the next approach is towards the documenting any software architecture is IEEE 1471 standard. Actually, it contains elements which define in this recommendation are viewpoints, views, and architectural models. Viewpoints are basically similar to view categories. And what is view? View is actual representation of a particular system. So views are view type of instances, and architectural models are diagrams where a view may involve one or more diagram, and these diagrams are we also have been discussed in our UML based lecture, which we have been discovered or discussed in lecture number 5, 6, and 7. Like there are multiple views which are used to describe any architecture is fundamental in the recommendation as well. Like there are different views from the perspective of different user, like end users, managers, developers, testers. All of these are different stakeholders who have different views about the system architecture as well. And now let's discuss the architectural documentation format, which is actually provided by this IEEE 141 standard. It actually contains six steps. Number one, overview of information, and the second one is identification of stakeholders and their concerns as well, and then the selection of viewpoints, and the fourth is one or more views, and then consistency among other views, and the last one is architectural reasoning or rational. So let's discuss these one by one. Architectural documentation format. So the number one is overview of information. Students, overview of information is basically providing us the overall summary of the system. So it also includes like details such as what the system is actually about, what the system will actually works. So it is the overview of information is the number one step in the IEEE 1417 standard. And the next one is identification of stakeholders and concerns. Identify the stakeholders involved together with their concerns like end users, developers, testers, project. These are the different stakeholders. So the minimum set of stakeholders must be include like user, acquires, developers, maintainers, testers, and project managers are also required in some cases as well. And now the third one is the selection of viewpoints. So basically each viewpoint should involve stakeholders, concerns, notations, and their associated modeling methods as well. And the next one is one or more views, or each view must include their introductory information, diagrams associated with modeling methods, and configuration information as well. And then we look into consistency among other views and architectural reasoning or rational, which actually includes the explanation of the thinking behind the selected architectural design. So these are, students, the most basic six, you can say, six elements or six components of architectural documentation format, which is actually being provided by this IEEE 1471 standard, which is a type of approach towards documenting software architecture. And students, now the next one is base approach, and this approach is basically divided into two basic parts. The first part is actually concerned or provide as a journal overview, which actually defines how the document is organized, what is system is actually about, like overview of the system information, and then a diagram which actually shows the mapping between the different views. And the last aspect of this general view is the thinking behind the system design, among other things as well. So this is the first part of this approach, which actually provides a general overview, which defines with the help of these four basic aspects. And now the second aspect of this base approach is provides the selected views in the following format, like primary presentation of the view, which actually is a brief explanation together with the graphical representation if possible in the relevant architecture. And then is the element catalog, which explains each element in the view and the relations. And then the context diagram, which actually shows the relation of views elements with their external elements as well. And this context diagram we also have been studied in our UML based lectures, lecture number 5, 6, and 7, where we see context diagram in the real world banking system examples. And the next aspect is variability guide. It actually documents the variation point, like specifying the valid option which can be selected. And so student, these are the different aspects, selected views in the following formats provided by the base approach. So this base advocates an iterative approach, which also named as the attribute driven design. So students, these are the different approaches towards documenting software architecture. So the most commonly utilized approach is the 4 plus 1 view architecture verification technique, and the IEEE 1471 standard. These two approaches towards documenting any software architecture are most commonly utilized. We do not have only these five approaches towards documenting any software architecture. There are a lot of other approaches are also available for documenting any software architecture, but these five are normally utilized. From these five approaches, as we explained earlier, mostly we utilize the 4 plus 1 view model, which is a basically architecture verification technique, and IEEE 1471 standard is the second approach, which is commonly or normally utilized. So among these five approaches, the 4 plus 1 view architectural verification technique and IEEE 1471 standard are the most commonly used. Students, you don't need to memorize these documenting architectural approaches. You just need to get clear about idea about how different views and how different standards are currently being provided in the industry to documenting any software architecture. So students, now who use the architectural documentation? So there are different roles in the our our in our software process industry. Like these roles are ranging from analyst, architect, business managers, customers, uh, business managers, if you see, business managers, customers, like deployer or developer, designer, implementer, and the integrator. Student, these are the different roles along with their descriptions. What are the description of their roles and what are the uses of different architectural documents in their roles, as in their roles, which are specified in these slides, are very well cleared. So students, if we look into the analyst, so students, the analyst is basically responsible for analyzing the architecture to assure that it meets certain critical quality attribute requirements. So where it is actually used is, so it actually satisfying of quality attributes requirements of the system, which actually based on its architecture as well. So there are the different roles and along with the descriptions and uses, where we actually seen that who use the architectural documentation and in which stages this architectural documentation is actually being utilized by the development team, ranging from analyst, architect, business manager, customer, deployer, designer, implementer, or integrator. So students, these two slides you can go through easily. These are self-explanatory as well for your understanding who actually utilize the architectural documentation in any project or in any system. So there are some seven rules for sound. What are the there are different rules for providing an effective, concrete, complete, and sound documentation. So these are the most basic seven rules to provide any effective, concrete, complete, and concise with sound documentation for any real world project. So the first point is write document from the reader's point of view. So students, you first need to write documentation from your reader's point of view. So students, what does it mean, reader's point of view? So students, uh, like find out who you are actually, your readers, what they know and what they expect out of the document, and you should avoid unnecessary insider jargons, etc. And students, jargons means the unnecessary things which don't carry out any meanings. So you need to avoid these kind of unnecessary things. And the second most important rule of this sound documentation is avoid unnecessary repetition. So you need to avoid unnecessary repetition. What does it mean? Like each kind of information should be recorded in exactly one place. This makes documentation easier to use and much easier to change as it evolves with respect to time. And now you should avoid ambiguity. Like you should explain your notation very clearly. Ambiguity means same thing should not carry two meanings. Like if you see in this ambiguity, like ambiguity normally occurs when documentation can be interpreted in more than one way and at least one of those way is incorrect. So you should always avoid the ambiguity with utilizing clearly notations. And the next rule for sound documentation is to utilize a standard organization. or to use a standard organization to provide any documentation. Like this standard organization, like as we discussed earlier, IEEE 1471 is a standard organization to provide a sound documentation for any software architecture. And this standard organization actually helps the reader to navigate the document and find specific information quickly, helps to the document writer to plan and organize its contents, and it also reveals what works remains to be done and the number of selected labels like to be determined or to do so as well. So using a standard organization is also an important aspect of any effective, concrete, complete and sound documentation. And now the next one is record rational. So record rational is what? So students, if you think earlier, as I discussed earlier, what is a rational? So in the students, record rational, you can say that architecture is result of making a set of important design decisions, and architecture documents records the outcomes of those decisions. For the important decisions, you should record why you made them the way you did. You should also record the important or most likely alternatives you rejected and state why. So students, that's why you should record rationally about thinking or reasoning. And the next one is keep documentation current but not too current. So what actually this point states? So documentation that is in it actually states that documentation that is incomplete or out of date does not reflect the truth or does not obey its own rules for from its internal consistency and is not used. Like, so documentation that is kept current and accurate is used. So because question about the software can be easily and most efficiently answered by referring to the appropriate document as well. So document that is somehow inadequate to answer the question need to be fixed as well. And now the last important point of sound documentation is review your document for fitness for purpose. Like only the intended use of a document will be able to tell you whether it contains the right information presented in the right way. So unless there are like before a document is released, you have to review it by representative of the community or communities for which it was written. So the review of documentation is the important aspect for check the fitness of purpose of any software architecture. So students, software architecture document actually you can say that provides a brief comprehensive overview of the system in terms of architecture, using a number of different views as we discussed earlier, 4 plus 1 view model, which actually depicts different aspects of the system. So why do we need software documentation? These are the three different most basic reasons, like knowledge sharing, communication and analysis. Like documentation is suitable for knowledge sharing between different people working in different functional areas, as well as knowledge transfer to new participants as well, is the basic need for documentation of any software architecture. And the next important aspect of any documentation of software architecture is communication among different stakeholders. Like start like any documentation is serves as the initial point for interaction between different stakeholders involved in the system, users, end users, testers, maintenance, designers, quality assurance engineers. All of these are different stakeholders which have different perspectives, and this software architecture documentation actually provides a way to communicate between these different stakeholders as well. And now the next last one is analysis as well, and documentation is also a starting point for future architecture reviews of the project as well. These three are not only the all of the reasons to that's why we need a software architecture document. There are some other points as well. So these are the most basic three concerns, or the reasons we need software architecture documents: to share knowledge, to communicate interaction between different stakeholders, and to provide future architecture reviews in terms of analysis. So these are the basic three concerns. That's why we need a software architecture documentation. And now, tips for writing a good architectural documentation. So these are the different tips are normally utilized to write any good software architecture. So let's discuss these things. So first one is avoid repetition. So students, don't repeat yourself, like work equally well as in programming and in documenting architecture, like create links, but do not write the same thing several times. So you should avoid repetition. And the next one is recognize from for whom you are writing. So what does it mean, students? Like perhaps the most important rule is this: documentation for developers and top management may differ dramatically. Therefore, it is necessary, students, to decide for whom you are doing it, and then understand what these people need in your documentation and what answers they try to find. So you need to recognize for whom you are actually writing this document to understand the architecture of any software. And the next one is avoid ambiguity. So in practices, one of the most frequent problem with documentation is ambiguity. For example, students, you came with a solution that is documented in the form of diagrams, so you understand it, you know the context, but the person who read it may not know it, and it confuse him what exactly you had in mind. Therefore you should always provide context of your diagrams as a description as well. So you should avoid your ambiguity as well. So and the next one is maintain relevance. Like in maintain relevance mean you should find a compromise between time spent and the relevance of the architecture. Like you can gain use the same formula, like if maintaining documenting is cheaper for a project, then the opposite way, like then it is right thing to do as well. And the last point is review documentation is the most important tip for writing any good software architecture. You should periodically, students, review the documentation so that you will most likely to find places that have lost relevance and are worth updating. So this review documentation, also try to share documentation with stakeholders and ask for their opinion as well. And this review documentation is especially useful when you are starting to document architecture as well. So students, these are the most basic tips to write any software architecture. There may exist many other tips as well. So these five are the most basic and the most important five tips to write any software architecture in my personal point of view, which I shared with you in this slide. And students, now we are approaching toward the end of our discussion about documenting any software architecture. And student, there are the different popular tools for creating any software architecture. Number one is MS Visio. Here is the link for this Microsoft Visio. It actually allows to do almost everything possible, and its one drawback is it does not provide us support for Mac, and it is not totally free. And OmniGraffle is also another type of software architecture. It is basically utilized for the Mac operating system, and it is also not free. And the other one is Enterprise Architect, and here is the link is also pasted for it. And actually it is paid, but mostly there is a 3 days trial period is also given by this organization as well. And the last one is the most basic and fast, simple and online tool, which is draw.io. It supports 30 uh, third party plugins, like ranging from C4 to AWS specific. These C4 to AWS are different plugins. You can do anything as you wish on any platform. ideal as a whiteboard tool for creating informal diagrams, and this draw.io is totally free. So students, not only these four tools are available to create any software architecture, there are plethora of lot of other tools are also available, like rational rows, like UML, and like rapid miner, and there are a lot of many others. There are you can say that there are more than 40 plus tools are available for creating any software architecture. These are only the few one which are the most popular utilized to create any software architecture. So students, let's summarize our talk about documenting any software architecture. So a perfect architecture, we can say, is useful if no one understand, if key stakeholder misunderstand it. So documentation is crucial part of producing a good architecture. So a document should be significantly abstract to quickly understood by new employees, like sufficiently detailed to serve as a blueprint for analysis as well. And any architecture document must have three main uses. Like architecture must serve as a mean of education, architecture must serve as a primary vehicle for communication among stakeholders, and architecture must serve as a basis for system analysis and construction. So this is my conclusion about documenting any software architecture. So students, still here our discussion of documenting any software architecture topic comes to an end, and our lecture number 27 is also ended.